Hey everyone, this is 2.5, so the end of chapter 2, woohoo! I'm going to talk about measure of position. So 2.3 was measure of center, mean, median, mode. 2.4 was measure of variation, namely the standard deviation. And now 2.5, measure of position. How are some ways we can talk about the position of a data value within an entire data set? So one thing you might have heard is percentiles. Percentiles divide a data set into 100 equal parts. And so about 1% of the data falls on or below the first percentile, which we would denote as P sub 1. 2% below the second percentile, etc. So number one here, suppose you were in the 75th percentile of a recent exam you took, for example. What does this mean? Okay, well, that would be denoted as P sub 75. Okay, and that just means that 75% of the data falls below or on that mark, right? So that just means then you did better than, or I guess equal to, 75% of the students who took the exam. Okay, so did better than 75% of the students. Okay, that's really clear, huh? But I set it to did better than 75% of the students. Check out my completed notes. It'll be written a lot better in that handout. Okay, the rest of this section is all on quartiles. So quartiles are like percentiles, except instead of dividing a data set into 100 parts, we're only going to divide it into 4 equal parts. Okay, so we're looking at just 4 equal parts. So about 1/4 or 25% of the data falls below Q1. Right? Half of the data falls below Q2. Q2, by the way, is also the median. Right? And then 75% of the data falls below Q3. All of the data would fall below Q4, which then would be the maximum. Okay, so for finding quartiles, here's what you're going to have to do. The first step in finding quartiles is to order the data set, because really it's all about like finding medians, just a lot of them. So step one, order the values. Okay, so I'm going to go ahead and pause and do an order. So if you want to order them on your own, and check me, pause. Okay, so there we have them ordered. And now we're going to find the quartiles. The first one you want to find is Q2, because that's the median. You already know how to find the median. It's the middle number. Here we have 11 numbers, so there is a middle one. If I think about the first 5, oops, I was erasing. The first 5, the last 5, 15 is right in the middle, right? So 15 is the median because there's 5 numbers to the left and 5 numbers to the right. Okay, so that's the Q2. Okay, next find Q1. Q1 is the median of the first half of the data. So if you circle it, here I circle it as an answer, don't use that number again when you're finding Q1s or Q3s. So for Q1, I'm just looking at those first 5 numbers, 4, 6, 7, 10, 13. 5 numbers, so there's a middle one, I can see it, it's the 7 because there's 2 to the left and 2 to the right. That's the Q1. Okay, and then do the same kind of thing for the upper half. 20 has 2 numbers to the left and 2 numbers to the right. That's your Q3. Okay, so there's finding quartiles. It'll vary a little bit depending on how many data values you have. That one was an odd number, so it worked out in that fashion. Let's try another one. Again, I'm going to pause it so we can order it first. So if you want to practice or work on ordering it, pause. Okay, so now we have 12 data values and we have them in order. So if there's 12, that means we can divide it up into 6 and 6. 2, 3, 4, 5, 6. 6 and 6 would put me right there. And so the median is right between 39 and 40, or 39.5, right? So 39.5 would be the Q2. Okay. Next, I want to find the median of the first half. So I have 25, 27, 33, 34, 38, and 39. I didn't circle 39. 39 is not the median, so I'm going to use it as a data value when I'm finding my Q1. Okay, so I can divide that up into 3 and 3. Right between 33 and 34, 33.5. That would be my Q1. All right, and then similar for the top, that would be Q3, 43. Averaging 42 and 44 would be 43. Okay, so here's a real good example of what these quartiles are doing. You're dividing the data set into 4 equal parts. Notice here we have 3 data values in each of the 4 equal parts, right? So my parts are part 1, 2, 3, 4. 4 equal parts, 3 data values in each part. And the quartiles are the dividers, right, for those parts. Okay, let's try one more. Oh, this one's already in order. Yay, that makes it a lot easier. So we can get right to it. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data values. So I think I can go and get a middle one. 1, 2, 3, 4, 5, 6. If I that 11, right, has 6 on each side. Okay, so I guess I should probably go back to blue. That's my Q2. Okay. And then I used it, so I'm not using it again. So now I have 2 through 10. There are 6 of them. So the Q1 will be a 5.5. Right? 5 and 6 averaged together. On the top end, 17 and 20. What's right between 17 and 20? Or add them up, divide by 2. That would be your Q3, 18.5. Okay, so there's finding quartiles. Next, there's what's called this interquartile range. The formula for that is just Q3 minus Q1, right? It gives a range of the middle half of the data, okay? What that can be used for is identifying outliers, and we're gonna use these little formulas for that. So let's get right to it. We're gonna find, for the data set from number 4 above, find the IQR and identify any outliers. Okay, so we're talking about this data set here from number 4. The IQR is Q3 minus Q1, 18.5 minus 5.5. So Q3 minus Q1, 18.5 minus 5.5 is 13. Cool. Now, are there any outliers in this data set? Okay, to find outliers or potential outliers, what we're going to do is, the first one is this little formula here. We're going to do Q1 minus 1.5 times the IQR. Don't worry about why it's 1.5. That's what statisticians have decided, I guess. So Q1 is 5.5 minus 1.5, and the IQR, we already found it to be 13. Okay, and then if I do this on my calculator, I'm doing, remember, order of operations, do the multiplication first, or if you just type it all at once in your calculator, it'll probably figure it out. But this, you should be getting negative 14. Okay, this is what's called a lower fence. And it's a marker. Anything less than or below negative 14 in the original data set would be an outlier. If I look at my original data set though, all of these numbers are positive. There's nothing that's less than negative 14. So the lowest I have is a 2. So there's no outliers on the lower end. Okay. How about the upper end? All right, so we're going to do this formula here, greater than that. So I'm going to do Q3, which is 18.5, plus 1.5 times 13. Right? Q3 plus 1.5 times that IQR. Right? So 18.5 plus 1.5 times 13 in my calculator is 38. That's the upper fence. Anything above 38 will be a potential outlier. So I go back to my data set. Do I have anything above 38? Oh yeah. Okay, there's the 55. That is an outlier. All right. Okay. So since 55 is greater than 38, 55 is a potential outlier. Or let's just say an outlier. Okay. I'll circle that. Okay. Finally, for this section, we have a 5-number summary. The 5-number summary consists of those 5 things: the minimum, the 3 quartiles, and the max. And a 5-number summary can be used to draw a box and whisker plot. Okay, so try this now. See if you can take this data set and find the 5-number summary. Okay, and then I'm just going to hit pause while you do that. Okay, so I put them all in order. There's 28 numbers, and so we can find the middle and then break the first half up into a half and the second half up into a half, and then we've got it, right? So if I want to write these down now, my minimum value is 0. My Q1, that first line, is 2. Right between 2 and 2 is 2. The Q2, which is the median, right between 4 and 4 is 4. The Q3, right between 5 and 5 is 5. And then the max is 9. Okay, so that's the 5-number summary. And then what a box and whisker plot looks like is, if you make it a little number line, the values from the minimum to the maximum, you start with plotting all of those values. So somewhere above the number line: 0, 2, 4, 5, and 9. Okay, and then there's a whisker from the minimum to Q1. And then the Q1 is where the box starts, and it ends at Q3. Then there's a line going through the median. And then there's a whisker all the way to the max. Okay, so that's a simple box and whisker plot and how they look. Okay, when we get to StatCrunch, probably do a little bit more with box and whisker plots when we have the technology. But for now, there's an example of how to create one. And that's it. Okay, I'm gonna stop there. Hope all is well.